Most organizations adopt artificial intelligence with a clear expectation. Cost will decrease. And at the level of an individual task, that expectation holds. Each output becomes cheaper. Each action requires less effort. Each decision executes faster. If evaluated in isolation, the conclusion is straightforward. Efficiency improves. Unit cost declines. But organizations do not operate at the level of isolated tasks. They operate as systems, and total cost is not determined by how inexpensive a single action becomes. It is determined by how many actions the system performs. This is where most models fail. Because when the cost of doing something falls, organizations do not hold activity constant. They expand it, not incrementally, structurally. A reporting function that produced outputs periodically begins producing continuously. A support function that responded selectively begins responding universally. An analysis function that operated within limits begins exploring every possible variation. The shift is not technical, it is behavioral. AI does not simply make work cheaper, it lowers the threshold at which work is initiated. And once that threshold moves, the system begins to change. In traditional environments, cost acts as a constraint. If an action is expensive, it is used selectively. Requests are filtered. Processes are prioritized. Output is limited. Cost enforces discipline. It determines what gets done. When AI reduces that cost, the constraint weakens. Actions that were previously evaluated are now executed automatically. Processes that required justification become default. Decisions that were selective become continuous. The system begins to operate under a different condition, not scarcity, but availability, and availability changes behavior. When something becomes easy, it is done more often. When it becomes inexpensive, it is no longer rationed. And when it is no longer rationed, volume increases. This is the central mechanism. AI reduces cost per unit, but it removes the constraint that limited volume. And when volume expands faster than cost declines, total cost increases. This is not a contradiction. It is a predictable outcome. Lower cost increases consumption. But inside organizations, the effect is amplified because consumption is driven by capability. When an organization can produce more, it tends to do so because output is interpreted as progress. More reports suggest more insight. More analysis suggests better decisions. More responsiveness suggests higher service quality. The system equates activity with improvement, even when cost is rising. This creates a subtle but important shift. Efficiency no longer reduces total spend. It enables expansion, and expansion drives cost. The more efficient the system becomes, the more expensive the organization becomes to operate. Consider a support function. Before AI, response capacity is limited by human bandwidth. Requests are filtered. Some are delayed. Some are ignored. Cost enforces selectivity. After AI, capacity expands. The system can respond to everything. So it does. Channels are opened. Response expectations increase. Volume rises. Each response is cheaper, but the number of responses expands, and total cost rises. Now consider a content function. Before AI, production is constrained by time and labor. Content is planned and limited. After AI, production accelerates. Generation becomes continuous. Output expands across formats, channels, and variations. But each unit still moves through a system. It must be reviewed, distributed, stored, managed. The system scales with the output, and cost scales with the system. Now consider analytical functions. Before AI, analysis is constrained by effort. Scenarios are limited. Iterations are selective. After AI, constraints disappear. More models are run. More variations are explored. More data is processed. Scope expands. And so does system demand. In each case, the pattern is consistent. Efficiency removes friction. Friction was the limit. When the limit disappears, activity increases. And activity determines total cost. This is why unit-level savings are misleading, because unit efficiency does not determine system cost. System behavior does, and behavior changes when constraints are removed. Most organizations fail to model this. They assume behavior remains constant. They calculate savings per task. They apply those savings to existing workflows, and they conclude that total cost will decline. But the workflow does not stay constant. It expands, because the organization adapts to the new capability. When something becomes easier, it is done more often. When it becomes cheaper, it is applied more broadly. And when broadly applied, it becomes embedded. The system reorganizes around the capability. And once that happens, the baseline level of activity increases. This is not temporary. It is structural. Cost is no longer constrained by effort. It is driven by volume. Effort-based systems scale slowly. Volume-based systems scale rapidly. AI moves organizations from one to the other. In effort-based systems, output requires proportional input. In volume-based systems, output requires marginal input. But marginal input across large volume becomes significant. This is where total cost rises, not because each action is expensive, but because there are many more actions, and each consumes resources. Compute capacity, processing cycles, storage, system bandwidth, individually small, collectively material, and because they are distributed across thousands or millions of actions, they are underestimated. This creates a visibility gap. Traditional costs are centralized. Headcount is clear. Budgets are defined. AI costs are fragmented. A small increase in compute. A marginal rise in processing demand. Additional infrastructure load. Each appears insignificant. Together they redefine the cost structure. But because they are distributed, they are not immediately recognized. By the time total cost becomes visible, the system has already adapted. Higher output becomes normal. Expectations adjust. Processes are built around increased activity. Reducing output is no longer neutral. It becomes disruptive. This introduces a second-order effect. Cost becomes resistant to reduction, not because efficiency is low, but because activity is high. And activity is embedded in how the organization operates. At this stage, efficiency is no longer the primary lever. Volume is. And reducing volume requires constraint, which is fundamentally different from optimization. It requires limiting activity. And limiting activity conflicts with capability. If the system can produce more, reducing output feels like regression. If it can respond instantly, delay feels like failure. If it can analyze everything, selectivity feels incomplete. So expansion continues. not because it must, but because it can. And this is the economic shift. Previously cost-constrained behavior. Now behavior drives cost, and behavior is harder to control. Cost can be budgeted, behavior must be governed. And most organizations do not govern activity, they expand it. This is why AI often increases total cost, not because the system is inefficient, but because it removes the constraint that kept cost under control. And once that constraint is gone, expansion becomes the default. More capability leads to more usage. More usage leads to more demand. More demand leads to more cost. Until a new constraint appears. Infrastructure limits, budget limits, operational limits. But by then, the system operates at a higher baseline, and returning to a lower baseline requires structural change, not incremental improvement. So the question is not whether AI reduces cost per unit. It often does. The question is what happens to behavior after that reduction. Because if activity expands faster than efficiency improves, total cost increases, not temporarily, but as a direct consequence of how the system now operates. And once that pattern is established, cost is no longer controlled by efficiency, it is controlled by volume, which means the real economic problem is no longer cost reduction. It is constraint, because without constraint, AI does not reduce cost, it removes the mechanism that kept it under control.